Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. I am Khusnul Khatimah as a representative of our team with title Research of Analysis of Temporal Change in Land Use and Impact of Water Resource in Delta Jeneberang Makassar, South Sulawesi. And we are from Geophysics Department, Faculty of Mathematics and Natural Science, Hasanuddin University, Makassar, Indonesia. So the outline of our presentation today is start from introduction, then material and method, result and discussion, conclusion, and last acknowledgement. We start from the introduction. As we know, Makassar is a metropolitan city with a population of 1.6 million or more, and the enhancement of industry activity resulted in a sharp increase in urban land demand. It is along with the increase in urban population, which is directly impacting the groundwater recharge as a storage of the water resource. Because this condition, the amount of municipal solid waste generated has increased with the population. We can see in the third figure, the R land use cover change from 200 till 2090 here. And because this condition also this research intended to analyze land use cover change implicate the quantity and the quality of groundwater as a water resource in the Delta Jeneberang River. The material and method we use in this research start from groundwater sample we are collected from 2 wells, 12 locations around Delta Jeneberang. We can see the point of the wells in the figure in presentation slide. And then we also using Landsat 8 data from the USGS and we processing it in the ArcGIS. After that, the analytical method was done in the groundwater sample, 12 groundwater sample. There is physical chemical parameter including pH that and the pH measured by PHT 026 multifunction water quality measure, and the turbidity parameter was measured by turbidity meterlutron TU 2016. And next, after the data we collected, the correlation between calculated parameter is pH and turbidity water sample analyzed statically through a Microsoft Excel using yin min u formula. In the first formula, R is stand for individual reading of first parameter, Y for this individual reading of second parameter, and N for number of value in single parameter. Next, water quality assessment is carrying out using water quality index from WHO from WHO, and to clarify the combinational effect of each parameter, also the qualitative parameter of drinking water quality. In the second formula, WI stands for relative weight of each parameter, QI stands for the quality rating, SLE for sub-index of each parameter, and the last we got the value of water quality index. Then in the table 1, the first table, there is a water quality rating of water quality index based on WHO, and the second table is the weight and the WHO standard value of drinking water. Then the result of our research first is physicochemical parameter, namely pH and turbidity of groundwater sample, shown in the presentation slide. In this presentation slide, then from the laboratory test, The value of pH and turbidity parameter in the 12 groundwater sample in the study area, several parameters for statistical analysis such as the average value, standard deviation, variance, and also correlation. We can see it, the average value of the pH parameter is about 6.605 and it's accordance with the WHO standard, whereas the for turbidity parameter obtained for 2.094 NTU. And for the variance, the measurement between are relative the same in both parameter. However, the correlation we found between pH and turbidity did not have a significant value obtained minus 0.47. Then after the statistical has done, the final computation from calculation of water quality index using formula 2, 3, 4, and 5 before uh, result the water quality index like the second table, but for the detail we give you example in the location 1 like this, and all these results indicate from the first location till the 11 location value is a range about 51 to 75, and it could be said that the water quality is poor and grading as a C class water. And for the location 12, and it's same as the fifth location, water quality is very poor and not suitable for drinking purpose because the water quality index shown value about 90.58, which is between the range of 76 till 11, and it's grading as D class. These varied results obtained are clearly caused by several factors like municipal solid waste generation increase, and the land use change from agricultural land purpose to urban land and impact the groundwater catchment area, and also the study area adjacent to the Jeneberang river flow. And the last result, we also carry out digitation in ArcGIS using Landsat 8, and we found out the land use cover change maps in study area, and the map for inverse distance wedge interpolation all for all water quality index in Delta Jeneberang, and it represent in figure 3. And we come to the conclusion. From the analysis of temporal change in land use and how it impact water resource in the Delta Jeneberang River, it is found that the correlation coefficient, a value between 1 and 1, could used to display how strongly two variables related to each other, and then statically analysis used for indicate the value of physicochemical parameter is a good measure before detailed observation about groundwater pollution because it is time saving, also cost effective. And the last is we can conclude that the accelerated rate of urbanization could impact the quantity and the quality of groundwater as a water resource. The results have shown that overall the groundwater quality in the study area needs to be treated before use, and for more detailed research, parameter of water quality should be variation to find out how much environmental damage has occurred on the same as the correlation result can vary between parameter. And this research supported by LPPM Hasanuddin University, Program Hibah Penelitian Internal 2020, and Geophysics Department, Faculty of Mathematics, Natural Science, Hasanuddin University. Thank you for the time. Stay safe and stay healthy. Wassalamualaikum warahmatullahi wabarakatuh.